Good evening, everyone. Welcome Obliterous, Aki, and Hexchen. While I wait for a few more people to join in, I'm going to quickly make some connections that need to be made. Oh well. So, to give some context for what today's stream is going to be about, you might remember last stream I was working on device firmware upgrade, DFU, and we got to a point where we had enumerating firmware, the bootloader, for which was having issues with one of its string descriptors, and we haven't yet tested DFU. Well, between streams, I spent a whole load of time. I found the onboard tracing stuff, and I started writing that up. But before I got too far into that, I tried a thing. The thing I tried was, well, so what if we make the descriptor shorter? And that works. Funnily enough, this descriptor works perfectly fine. So something is wrong with multi-packet string descriptors. We've got to come back to that. However, for right now, what this means, I did a whole pile more prep stuff here, is if we do a DFU util listing, we see our bootloader, small descriptor. It's still quite big, actually. So you have to double the number and add 2. So while it's only, in quotes, only 28 bytes, apparently, that's actually 52 bytes plus 2 for the 2 prefix bytes. So it's quite a big descriptor. It's chunky. Anyway, we've now got that working. But as you can see, DFU here ain't working. It ain't happy. Sorry, just opening a drink. And we're going to try and look into that tonight. We're going to try and figure out what's going on, why, and fix it. I hope everyone's doing well. So, with that, let's get into it. God, I sound very brutal, like saying, let's get into it. Okay is good. I'll take okay. Or pat. All good. So the first thing I spotted when doing a DFU try, which let's just quickly do one, is that it thinks it can't do a get status. So let us spin up the analyzer and find out why. So we've got it doing the get language descriptor, get a descriptor, standard out on an interface, set interface. This, that's a really good thing to see actually. This should be setting the alt mode for the interface. And then device to host, we have set feature, which stalls. Oh, interesting. And that's both of those are interface requests. So let's see how we're dealing with this at the moment. We have handle DFU request comes in. We are then checking that the recipient is the interface, and we are not currently handling standard descriptors for that. Oh, interesting. Are we doing anything for that here? So set interface. Full mode handlers. Let's actually see what the USB spec says about set interface. I'm betting I'm implementing it slightly wrong at the moment. Interesting. So if it's set as an in-mode transfer, we fail. That's fine. This is supposed to be a standard request. There is no validation going into this. Hey Freya, welcome, welcome. Okay, so there's a lot of apparently missing checking happening, not happening here. So if packet dot request type recipient device, I think, is the 0th. Yeah, so if it's not the device, which is all of these ones, or request type Oh, wait, no. Set interface is set as the low bit is 1. So that actually means that this is going to be looking for it to be an interface request, which needs to be done inside get interface, or set interface rather here. So let's put that where it should be. What we're looking for then is for this request type to be a request type standard. There we go. So if handle standard request gets passed in something that is not a standard request, we just ignore it, skip over. That's important because these request numbers overlap. Let's see, so we then have set interface checking that the type here, if we double check, request type recipient should be an interface recipient. And we actually need to do validation in all of these for that kind of thing. We are currently not doing that, which is bad. Likewise, get interface should also be checking that the recipient is an interface and so on. So we've then got class specific request set feature, which is currently being stalled. I'm betting that now works now that we've fixed up that routine. Whoops, that was not the line I wanted to run again. That's what I want. So let's put the new bootloader on. Looks promising. And we can see the endpoint. And that still fails. Interesting. So, if this was going to the specific interface, O3, what is 3? Okie dokie. Ah, indeed. Ah, here we go. 3. Get status. So yes, it's saying that get status is not implemented, even though we know let's get state. That's not USB types. Request T, that is DFU's one. Oh, welcome, Goat Sarah. Zara, rather. So this is the bootloader stuff that I've been working on. It implements DFU, the device firmware update protocol, or upgrade protocol, depending on who you ask. It is technically upgrade though. And we are currently debugging why my bootloader no talkie properly. Specifically here, ignore that this says that it's set feature. It's not set feature. 03 here, because this is a class specific request and it's on the interface recipient, is actually a DFU get state. As we can see here, A1 03 get status, and it is getting stalled. So we're currently trying to debug why is it getting stalled and how to fix it. Hopefully that makes some sense. Now, for some reason, my IDE is not very happy with me right now. I'm going to actually ask it to rerun linting, etc. on this file. Ah, no, no change. For some reason it thinks it's the USB types request T, which it is not. And that's why it thinks it's set feature, which it's not. The compiler knows what's up. I wonder if I maneuver what header that's in. Include USB drivers, DFU types. This is currently in the DFU types namespace. But if I put request T here in the USB DFU namespace, now it resolves properly. Okay, that's better. So it should be triggering this. And the direction bit, the high bit, should be set, so this shouldn't be why we are stalling. Instead, we should be returning data. What this implies is that this routine is not running. We look here. We've got address, descriptor, configuration. Yeah, let's continue writing validation for these, because clearly something is missing. And it's falling through in a bad way. So we've got set address, which should only happen as a standard out request. To the device. We've then got set descriptor, which is also same, must be to the device. Well, actually we don't need to do any validation there because we only have a stall for set descriptor. Get descriptor, get handle get descriptor. This should also check the recipient. Set configuration is also only able to be issued to the device. Get configuration is probably the same. Yep. Get and set interface are issuable only to the interface. And sync frame is only issuable. Well, I stall only anyway at the moment, but it's only issuable to an endpoint. That leaves yeah, set feature at the moment should be going through to unhandled. But also we shouldn't be going through here because it should be immediately going unhandled. Because it's not a standard request, it's an interface specific request. I'm of the mind to make sure I'm in a debug mode and do a GDB based run of all of this. And we are debug optimized. Optimization level G. That's fine. Yeah. Okay. That's a good sign. I'm gonna need another console. And this is to grab the DFU commands out too. Hey, Lofty, welcome, welcome. That was fun. I've got a bug in the keyboard firmware I need to fix at some point, which needs this bootloader to fix. Chicken and egg. Let us do a breakpoint on line 95 here of the DFU firmware. Break DFU CXX line 95. Run. And no breakpoint trigger. Hey, my Aegis, welcome, welcome. Broken breakpoint. Yeah, maybe. I'm gonna first see if I can reset things up. Ooh. Okay, so if I just run continue at that point, it should be good to go. There's a possible bug in Blackmagic Probe that I'm tracking here at the same time, which is fun. Thank you, Freya. How far did I progress? I am having, at the moment, awful problems with the interface-specific requests. I also use Arch, which is quite fun, as I've had a couple of the Arch people go and follow me recently on Twitter, which is a bit, hi, okay. Cool, I guess. Yes, Benita's videos are actually very, very good, I think. I know, Hexgen, you use the weird one. Though I get it, by the way. I do actually understand, Oh, maybe. It's still a little weird to me. Like, why are you people following me? Yeah, it really keeps going down the wrong route. So, Obliterous, is that related to Demo or Die? I think I want to actually put a breakpoint as well on entry into this function. And that's still... Yeah, go at Sarah. It's breakpoint, as in the demo party. I am currently running a 5950X, and I am very, very glad I finally upgraded from a 2700X. So, you know. A Blit, you're welcome to buy the CPU, the old CPU off me. Yeah, that's fair, a Blit. My Aegis, you probably can't get a hold of the 3000 series anymore. You probably have to go to a 5700X. But they're actually about the same price if you know where to look. So my question at the moment is, why are breakpoints not triggering? That's fair. Understandable, Hexgen. But you know my workloads. You know why I've bought it. So... I mean, let's be fair. There's more power, and then there's just... Now my face is on fire from all of the heat and power. Yeah. Whereas I was, it's not just KiCAD 90 my Aegis, but yes, doing the check builds of that takes a while. But I've also got other loads my Aegis that, stress things. Try not to laugh too hard, okay? You're allowed to be kind to past you. So let's see what happens if I put a breakpoint in here. I'm at this point clutching at where will the breakpoint work? Let's do delete 2 and 1, break. Device CXX line 307. Whoopsie. Colon, not at. Okay, I'm able to get it to do the thingy thing. You're actually not that far wrong. Why? So, I would be using VS Code's debugger, but it doesn't really play nice with this style of debug, unfortunately. Well, it can be made to, but... Step. Well, before I go stepping anywhere, I'm actually looking at this and I'm going, control handlers is for some reason, null. And it shouldn't be, there should be a valid handler. So, we found a bug, not happy about it. Debug revolution. I like it a lot. So, control handlers, let's see. Register handlers. Register handler. Of course. So we've got interface count greater than or equal to 1. GDB. Yeah, well. I bet this is because I'm putting interface 1 in here. It would be really helpful if it would tell me the help for that. Let me open that up. So this is because I'm putting the wrong interface number in here. My bet is that that will now just work. Aww. Pats. Oops. Run that actually. There we go. Okay, so that worked. Clearly. So we've got not set feature, but the get state thing causes us to send back that. Standard to interface, set interface. Okay, so that sets up stuff again. Okay. Huh. Warning, runtime device already in DFU state, but it's not a runtime device. Why does it think it's a runtime device? Let me pop my Blackmagic probe, a Blackmagic probe, yeah, this Blackmagic probe, into its bootloader mode real quick, and let's see what the descriptors say. If I can get the button to press and hold while I plug things in. Okay. So this is Open Moko rather. PMP DFU. Brand DFU. Okay, interesting. Oh well. What does interface protocol 2 mean here? You gonna help her implement it then? Mode device descriptor. Ah, that's what it's for. Okay. So if we go and fix our descriptors, this is interface descriptor. Ah. Protocols application DFU, we actually need to go and put that in the headers. Which will be somewhere in the USB library. Do I have that open? I do. Oh, good. Very, very cursed. Thanks for asking. What else needs fixing here? So we've got application-specific interface, DFU. Protocol is then DFU. Oh, right. This should actually be in the namespace of application-specific stuff, DFUT. I'll break a few things first, but, you know. Yeah. How cursed? Yes. Agreed. Will detach, manifestation intolerant. So let's just quickly get Blackmagic Probe back up normally. On 209, bad B. That's better. Just quickly looking at these links. Come on, Twitter. Twitter's being slow on the laptop. Okay, so now we've fixed our descriptor. It knows it's in DFU mode right now. So let's see what happens now. It should say that it's in DFU mode, and that's good. Yes. But could not read name, scanf return 0. What on earth is it doing with that? I'm gonna need to get the code for the DFU util up. One moment while I grab a Chrome window from a different workspace. I happen to know it's on SourceForge, unfortunately. Because it's not HTTPS, etc. So, this is DFU util that we're playing with. I need the version 0.10 sources. And we are already in DFU.c. So get status here, this is us, well, I mean obliterous, you can ask me about the Audacity situation if you want. DFU, it standing for Don't Fuck Up, just makes me think of Hacker Jeopardy, which is absolutely, yes, this is Hacker Jeopardy. Duh. So my take on Audacity is this. There are some factions of people blowing this completely out of proportion. The source code is there for you to read, and you can trace exactly how they make their release builds, because it's all done through CI. Yes. And the other thing about the Audacity thing is, if you're really that concerned about telemetry, pull the code to your local machine, verify the build system actually turns the telemetry stuff off, which it does by default, build it yourself, and use your own build. That's really all there is to that. I think that there have been some issues that have happened as a result of the overinflated reaction that have resulted in real people getting hurt over a piece of open source software. This is just stupid at the end of the day. It's not worth dying for a piece of software that is open. Sure, you can manually turn the telemetry on in the build. However, even with a telemetry enabled build, which is not the default, the telemetry internally is still off by default. You actually have to manually go into the settings and opt in to sending telemetry data. It's hosted on the Muse group servers. It's opt-in, not opt-out. It's local hosted on their servers. They're very clear in their privacy policy why they're doing it. And the one broad category is the law enforcement one, and the only reason that's in there is because they know that they can be sued out of business for not putting it in, and for not answering law enforcement. Which is a sad state of affairs, but it is how this world works. And you know from what they're collecting that the only thing they've got are crash logs. So, fine. I personally wouldn't mind turning telemetry on for them, because if they've got things they want to fix and I'm experiencing those things, more crash reports better. No, so they didn't have to make it PG-13. They, not in all countries at least. There are certain countries, US, where gathering information on children is illegal unless there are specific, very hard to instigate safeguards put in place. Rather than putting themselves through that legal ringer, privacy policy says you either disable telemetry, or if you have it enabled, you can't be a minor. That's fair. They don't want to get caught out by copper. That's what that is about. Does that make sense? I hope that makes some sense. Oh, you're fine. I recognize that name. Find descriptor. No. Utifate string descriptor. Oh, so this is why it always gets the line descriptor. Okay. What I'm looking for, by the way, I'm sorry if being so quiet for a moment there. Fair enough. What I'm currently looking for is where is this scanf, and why are they using scanf, and what are they expecting the format to be? Because the spec makes no mention that your string descriptor has to be a specific format. So this is where it prints out the what it's found. So far I've not seen the error message we've got either. What I should probably do is I should probably take could not read name and do a find for that. So far I've looked in DFU C, DFU util C. We've got load, maybe? It doesn't appear to be in here. Do upload, do download. I am tempted to make a clone of this and do a local search. Yeah, let's do that, because this is going to be far less painful to do locally. Yes, because git clone does not work. Derp. Hey Aki, welcome, welcome. Aww. Ooh, another Minecraft server, huh? Fair. Hey Amy, welcome, welcome. I am having a time with, DFU util. Oh, because of course I would have known that it was in defuse mem. Oh my god. What? Oh, I hate this. Also, this is a giant pile of security vulnerabilities. I hate this. This is awful. Oh, nice. I know you've been fighting Visual Studio quite a lot. I'm glad that it's paying off, as it were. So this string descriptor is still... C doesn't imply security vulnerability. Scanf does. The problem is that that entire chunk of code needs completely rewriting to remove its dependence on said broken function. It's not simple to fix, and it's a mindset problem as much as anything. So this needs to be at DFU, because otherwise it doesn't match the thingy thing, slash, to match the start of the thing. And then we are... I think that's the right offset that we declared. Look in the linker scripts now. Yeah, that'll be the right offset. I'm trying to do as compact a descriptor as I can. This explains why this is such a horrible piece of text. So my problem is that my nice device firmware update descriptor ain't gonna work. Is not gonna cut it because in DFU mode, DFU util parses that string descriptor for memory layout, which is itself interesting and a cause for concern. But worse than that, it does it with scanf in a way where if I put the wrong kinds of numbers in, it's going to blow past. For example, address is a raw unsigned int. If I compile DFU util on a platform with 16-bit integers, yes, unfortunately. Then the scanf can overflow that number in an undefined behavior manner because of the way that scanf works. Especially as they're not doing unsigned scan, they're doing signed scan for that particular value. And just all kinds of bad ways. I have proper routines for this kind of stuff in Substrate, so I can do this safely, but that would be a different stream. Right now what I'm currently trying to do is figure out how, and this is the other problem I have with scanf. Scanf here doesn't really describe... yes, exactly, Aki. Scanf here doesn't exactly describe very well how to format what I'm trying to parse out. So, like, what's this number? There's a star token, okay. What's this other number? What's this %C doing? And... it's bad. It's very bad. So I think this is 8 sectors by 1 kilobyte. And then this other bit is a separate part, which I'm not sure how I interpret. Sure. Because I don't really want to write a DFU util thing, but I'm apparently going to have to make this not terrible, and publish it not on SourceForge. This is also where I'd really appreciate it if I had Esden in chat, because Esden actually does know how this works. Kind of. Maybe. He is online. And I have an old friend pinging me on Steam. Hi, old friend. No, I'm not going to publicly say who you are. I know. Oh, probably. Probably. Oh, I also pinged him. While we wait, let us see if I can figure this out myself. Hey Eston, I am having problems with DFU util and the whole parsing of descriptors, and I'm not sure how things are actually laid out. I need to verify my understanding. So, reading the DFU util sources, because of course I'm having to, I think with this godforsaken thing, there's sectors, there's then a size and a multiplier. Am I right in saying that this descriptor here yeah, well, yes. I wish it wasn't using scanf though, because security vulnerabilities. Okay. Am I correct in saying though that this is 8 sectors of 1 kilobyte each? Kibibyte rather. Hey Sylvia. Any chance of a link then, please? Because, yeah, I thought defuse was the name of the file format that the standard called for. Okay. Okay. The .dfu file format, though, is in the spec. Just saying, and it's also called defuse. Ugh. Okay. Thank you. I appreciate it. Because this doesn't play ball if you don't use that string descriptor format. No, you can't. DFU util will not work. Sylvia? It ain't working. I might as well implement this just so that this works. It's complaining that it couldn't scanf out the DFU's formatted memory region stuff. Oh, is that what the A's for? Okay. At the moment, my string... I didn't mean to minimize that one. I meant to click on the other one. At the moment, my string is at DFU / and then the address of the end of the bootloader. And I'm trying to figure out what I put after that. Which... I'm trying to find where it actually specifies this string descriptor. To be honest, I don't care as long as it works reliably. I only have one memory region that can be programmed. It comes after the bootloader, but the tool does not need to know that. Fine. In that case... that. Thanks, Sarah. Thanks. Thanks, Rhea. Again, even though I'm saying I am DFU only, warning defuse option on used on non-defused device could not scanf. Oh, really? That's non-compliant with the spec. The spec specifically says that the DFU specific functional descriptor, where is that gone? It's down in... Huh. Specs are not really suggestions, I think. They shouldn't be treated as suggestions. But okay. Because this is all about conformance at the end of the day. Yeah. Numeric expression identifying the version of the DFU specification release, and this is 1.1. So it should be 1.1, not 1.01. Oh well, let's do the non-conformant thing then. No, because of the way that they did the, binary coded decimal, USB 1.1 is 0110, for example, not 0101. So going by the main specification, you can't interpret it as 10, it's 1. Well, I mean, you're clearly not wrong according to DFU util here, because they still thought this was a blasted defuse device. Yeah, it's still trying to do parsing the string. And even if I take out that, which is a defuse specific option, really? Huh, okay. Ah, okay. Wow, that is kind of mental. Okay. So, this is now failing. Okay. That's stupid. Which probably is why the extension of the spec, right? libUSB error pipe. But it didn't transfer, and it... Oh, this is the stuck transfers bug, isn't it, Sylvia? Where USB is not going to show me what's happening until something else happens, if it ever even gets to show me the packets, right? Okay. It's fine. So... this is gonna suck, isn't it? This is the table I need. So we have x21, which matches load here. So this is interesting that it stalls as a response. We want it to not show page 31. Thank you. Okay. It is. So what it's saying is that I should actually be saying that if I use the DFU style descriptors, I should be saying this starts at 0, and then describe the bootloader's area which is readable, and then describe the firmware area which is readable, erasable, writable, that's the G, and do it in multiples of 1K pages or something along those lines. Okay. Oops. I will do so in a moment. So this would be 16 star 1K A. And there's comma to continue to a new one, and then however many pages are left of my 256K, so it's 256 minus 16, 240 star K, 1K that is, and make it the thingy thing. So this is the spec that Eston's linked me. The way that this works is you specify how big a page is. Sure. This is a base address. This is a number of the multiplier here. So in this case, for example, this is 8 by 64 kilobyte pages that are being marked as readable, erasable, writable. In the case of our bootloader, they're readable, but not erasable or writable. In the case of our main firmware area, they're readable, erasable, and writable, which is why A and G following the K. And instead of encoding multiple regions like this, which I could do, what I'm doing is I'm using the prior sector type, comma, sector stuff, etc., where you can specify multiple chunks within the same region with a comma. Which hopefully makes more sense now. That's what that really horrible C code is trying to do. This. Yeah, with no comments, and with some whacking great big security vulnerabilities in it, which is great. Right? I'm gonna be rewriting DFU util in a future stream. So there's that. Gosh. You're about as good as HexGen with the bad puns, and therefore also as my best friend, well, one of my two best friends, who's not in chat right now. Pass. I was planning to do it in C++. Because I have some really, really nice parser code that's stuck in Substrate, which is a C++ library, which makes doing that kind of stuff really easy without introducing vulnerabilities. Thanks, Aki, my other best friend and wife. Yeah, so, but Freya is the other person who's really good with the puns like that. So, that's a bit of an aside though. So, doop. Back on intestine. At the moment, Vizsla is telling me that we are decoding the request type correctly. Yeah, so this needs to be done on hardware, which is the problem. I can unit test some of this code if I set the right harness up. For example, I could unit test that handle DFU request on a given packet, etc. in user space. This is does the right thing, but as soon as my code starts poking hardware, we're done. We can't unit test. We have to run on real hardware. And part of this is down to me just not having yet found the spoons in time to actually go and set the test benches up. I will do it at some point, where possible. Take care of Blip. So, we are currently decoding the... Or I'm assuming we're correctly decoding the starter download packet. Download is 1. Download is 1. We expect that bit to be clear. Thanks, Eston. So, my Aegis, with regards to this, because the USB code very quickly as you go up the call stack, or rather down the call stack, starts hitting hardware, it just becomes infeasible to reasonably put together unit tests that prove anything. Like, okay, it's writing hardware, I can emulate the writes to I can emulate some space for it to write to hardware, but then, like, okay, so what? And that would require DFU util. Oh, sure. DFU util itself could probably get some unit testing, but it's C, written in the most C way possible, so of course no one's unit testing it. So, I keep trying to get back to this, which is that we've got this high bit here is not set, therefore the check here should not ping. We should not be stalling because of this. We enter handle download, noting that the type recipient is interface, and this is a class mode message. Which is for the correct interface? Yes, which is for the correct interface. So handle download. Ah, we can stall if this happens. So let's do the smart thing and let's run GDB on this. So this is DFU CXX line 70. Uh... Oh. So even in C#, there are things you can do that unit testing becomes economically unviable to do. Because you basically end up testing ghosts. You have to put so much shimming around the test, or around the thing you want to test, rather. You have to take it so far out a real environment that you bake so many assumptions in that you can make the tests do whatever you want and pass however you want. At which point you're not really testing it. And it also takes too long to write those kinds of tests. I like unit tests as much as the next person, but yeah, I recognize their limits. That's quite important. Oh, for the love of... I think I've managed to get... Yeah, I've managed to get Black Magic Probe into a state. Ah. Give me a moment. I managed to break Black Magic Probe. It occasionally happens. Better. Before I run that, I actually need to set the breakpoint back up. Okay, the bootloader came back this time. Oh, interesting. This is almost as if the set interface stuff isn't firing properly. Because none of the pointers get set up. Oh, no, I know what's happened here. I didn't yet put the zone information into bootloader CXX. I'm a dumbass. I definitely do get set interface. And also the spec here requires it. Or at least it seems to require it. I am getting set interface though, regardless. It's just I haven't set up a zone T. So the zone needs to say start and end. Zone T firmware zone. Start is that. And the end of the zone is going to need to be as hex that apparently. Oh, that's Dragon USB, not SPIFlashProgrammer itself. Fools. Yeah, because this linker script doesn't actually say how big the chip is. I mean, that there should be a set configuration. Sorry, not a set configuration, a set, I'll rerun the USB proper in a moment. I'll show you what's happening. But before we do that, I need to fix this other bug. Just hold your horses. SPIFlashProgrammer. That's what I was looking for. Okay, yeah, the number I've calculated is correct. It's not pleasant, but it's correct. Sure, I can make it not depend on that later, I just want to make it work first. So, it might be that the way I deal with set configuration causes all of the interface handlers that have just become active to get called once to set default state up. For example, that's a USB stack problem I can fix though. The span here. Okie dokie, take care. And sleep well. Oh. Thanks, Maegus. Agreed, Aki. Although here it's more like it's just too freaking humid. I'm melting because of the humidity right now. But I'm otherwise cold. Not pleasant. I'm guessing over there it's like high 20s. Eesh. So high 20s, but high relative humidity as well. That's not fun. I'm trying to remember how spans are constructed. Pointer and account. Pointer and account. And there are... Oh yes. I keep accidentally hitting the wrong key on my keyboard. I keep hitting caps lock. That's a lot of tabs. Oh, it knows the size of the span at compile time, so it does stuff. I wonder if that then allows me to do that. Nope. I apparently have forgotten entirely how spans work. Oh. Just trying to think about how best to go about fixing this, because this is kind of obnoxious. Let's do static const substrate span firmware zone span firmware zone. if subspan is called, for offset 0, we can get a dynamic extent span that way. Yeah, fine, the other way to do this is to do a dot begin and a dot end. Because that is the essence of a span. I just spotted the bug. This is because I forgot that const zone t and zone t are two different things. We want a const zone t going in, and here we also want const zone t because we do not want to be able to modify the zones, but we do want to be able to modify the span that we're holding on the zones. And I bet that now I can just hand in a array, and it just works! Yay, there we go. So all of that pain entirely was caused because spans are twitchy about their const correctness. So, Sylvia, I said I would rerun a USB tracer this. So here goes. And there's our set interface. So for the moment, that's fine. In practice, yeah, probably don't rely on that. Let's find out now what's happening in the firmware and why it ain't liking us. Well, that's a very interesting place for us to have broken into the code. Huh. DFU, CXX again. We probably want to break back in at line 70 here of DFU CXX. Which, if we now run, flash state, there we go. These are now correct. and we have a correct end address. No packet in there? Oh, right, because this is in USB device. Okay, so that looks like that's 1024. And if we do flash state erase address to flash state and address, smaller than the end address. Okay. Whoops, I core dumped my debugger. That was predictable. Let me reboot the hardware again, because I just screwed up the state of everything. So we are now at least getting down to read EP ready. So we're telling data coming into us needs to go into buffer.data. I should probably also check that the packet length does not exceed that value. So that we know that we're not going to exceed our max transfer size here and blow past the end of the buffer. Next, read EP ready. Not read EP ready, continue. Which is a loop on RX ready. And then we try doing the read. Let's try that size. So what this should do is it should continually loop through this inner loop waiting for the endpoint to become ready with more data until we have actually read all the data required for the set of transfers. Wait, now that's not required because of how we're doing things. Never mind. That. Oh, right. We actually can't put that there because we need to do this zero length business. Ah. I think I now know why the firmware was not happy. Let's run Vizsla again. And try. So we have setup. This sets up the download. We then have an out token with data. That should be 64 bytes, and if we look at the input file, dhex SPIFlashProgrammer bin 000100022b 580000, and that matches. Yeah, that matches that data. So we acknowledge the first lot. We then get another out token with more data. The next 64k, sorry, 64 bytes. That matches, and then for some reason it then stalls. So we're able to do part of the DFU protocol, and then it starts stalling. How curious. So this should be going through handle controller out packet, which is in this main file. Setup packet, controller out packet here. If we're in the data receive phase, then we do a read EP0, then we go into a status phase, which then should trigger an in packet to happen. But we're not getting that far yet. Why? Packet. Also, I should probably copy that code and plop it in there too, because it doesn't matter if we're in status because of an out packet or status because of an in packet. We should still call the action requested back. Welcome back. So we should be entering this setup out, 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 in mechanism. So I'm having a funny feeling it might be going through this. Because I should be marking the endpoint as needing arming. Vizsla needs a reboot. Wonderful. Interesting. That brought about absolutely no change in the way that this is working. Why? I'm trying to work out why this would that doesn't make any sense. Unless my stack is quite severely wrong. Data TX, data RX rather, which when we next see an out packet we should then read, and if we've got everything then we go into TX, which should put us here. Not needs arming. Oh. This is my fault. So this needs to take what was set up in this is an in packet. This is zero length packet territory. We generate a zero length packet at the end of a series of out packet transfers. EP status controller in zero. Let's make that a reference like I did in that other function, which is here. And this should be doing something that doesn't require the arming to happen. So this is a two-pronged bug. Fun. So set up the memory buffer, set up the transfer count. It doesn't matter too much in this case, but the memory type might as well also get set up as memory T SRAM. And oops, that was not where I wanted to be. We need to arm and not stall. So that's our status transfer. That means that the answer to download here should be stall. I'm gonna make that less crap later. Because what I should be doing is I should be checking if the controller inside of things is set up for transfer or not, and turn a result of ZLP into not ARM, unlike here. Yeah, there's some things that need fixing about this. Actually, I can fix that right now. What needs arming here needs to do is check that EP status control out 0 needs arming is false, and we said that the response should be 0 length packet. I'm happier with that fix. Because that means that most of this stuff is actually already set up for us. Like the memory type and the transfer count. And it just needs arming that will need fixing. And what that should do, because needs arming will now be false on in, true on out, we go into the data RX mode correctly. I just fried my brain very slightly with that. It's still breaking. GDB time. So we want to verify that we are actually ending up in data RX mode. So that's device CXX line 243. We should also verify that we end up here in the data phase, read the thing. 336, that is. That's a good sign. That's because that's USB core. So data going to the PC, null pointer, data coming back from the PC. That looks correct. That looks correct. We end up here, that's good. However, EP status controller out is unchanged. That's not good. Status controller out. Endpoint should be 0. We are looking at out. Yes, we're looking at out. Read count is greater than the maximum size of the transfer count size of the endpoint, which is fine. We'll clamp it. Should then be decrementing this, which we are not. trying to read the data out, and then marking the data buffer is done with, returning if transfer count is false or not. Why does it end up there? Try that again. What is that defined in then? Oh, core internals. Okay. Data RX. Data RX. That matches. This is USB control, EP0 control. The RX count is indeed 0. I and status control L. Oh. Is this the processor goes into a bad state again? I was not expecting to have to debug the USB stack. Ugh. USB is hard. This is it saying that RxRDY is true, but there's nothing else on that endpoint. That's what status control L being 1 like that means. There is a FIFO. I could technically read it out if I want to. It does mean that the stack will be out of step with the hardware, but I want to prove a point. As system control, PGMA. Ah, it's the endpoint 5 first there. So EP 500. Oh, fine, we're doing that apparently. You get the idea. We can read out data just fine. There is data there. And this explains why nothing happened. Because status control L is now 0. That's kind of grim. True when all the data to be read has been received, which is also the only time where we changed the state to status TX. I am confused. As to why this is saying read is ready and then no data to be read. I know that what this is doing is fine because we're poking around inside the output side of things. That's from PC2 device. We're changing the buffer, we're changing the transfer count. That can be done at any time because of how the stack works. Needs arming gets set to true. We set up a callback. And the callback is making us go into the download sync state, which is fine. There's nothing here that beyond the device itself messing things up should be causing a problem now. We have just gone and fixed the bug that was in the stack. And yet, this is doing mad things, and it doesn't make sense. Because this is going... skipping over attempting to do the right. We have no response, but rather we need more data, we don't do stall here, we'd know about it if we did. Which should mean that we end up in here, which we do. Also, one thing's bugging me. I'm going to change how this is written because this is bad. Like that. How's everybody else doing anyway? I'm just quietly going mad. Slowly but surely. As code doesn't work how it should work. And I get stalls that I shouldn't get. Aww. That looks fine. And then the download fails. Ah, that works. So this is interface 5. I'm doing stuff in Wireshark real quick to see if I can help myself any. So let's reset the firmware and try that again. And we get there's our packet going out saying, here's some data, and then we have the data. And I think this is it saying I stalled. Broken pipe, yeah. This is the stall. Oh, that's quite a challenge. Gambatte. Oh, am I accidentally again triggering the auto stall stuff? I might be. Nice. So we can kind of ignore the DMA side of things. We're using the advanced hardware bus, the high speed, sorry, not hardware. And that's putting data in through the FIFOs, which then does the packet encode out the interface. So, additional actions. The USB controller responds automatically to certain conditions on the USB bus or actions by the host controller. Stalled control transfer. The USB controller automatically issues a stall handshake for a control transfer under the following conditions. The host sends more data during an out data phase of a control transfer than was specified in the device request during the setup phase. But that requires data end to get set. Let me just open the spec, or rather the datasheet for this thing a second time real quick. Electronics, stocks, micros, this thing. And we are in the USB side of things. Side pane F9. We are looking at register map. And this is handled by endpoint 0 low as well. We've got RxRDY, TXRDY, stalled, data end, set end stall, RxRdy set end. A control transaction has ended before the data end bit has been set. We have a hack in the stack at the moment. Where is that? Here. Haha. That clears that setup end bit for us. Let's see what happens without that hack. We also have it automatically clearing the stall condition for us, which is fine. I almost feel like I've just managed to break the stack further, but we'll see. Okay, that enumerates. Not that that's easy to tell, but that did enumerate. Do I have this running? I do not. Let's have that running. That's unhappy still. In the same way, oops, that even. The stack is idle. Oh, I should not have run Visitor at the same time. That makes life infinitely harder. Okay, so we've got set interface, the in transfer that sets up get state and the get state itself. Then we have the output transfer, which says broken pipe because this is a stall. No, I'm below the old data. I should probably restart Wireshark though, so it was a little clearer. My bad. I mean, here was that original transfer run. Complete with, where has it gone? Oh, bloody hell, you are correct. There's it doing its thing. Set configuration. Get descriptor. Get descriptor. Set configuration. And then there's FTDI stuff. Because Vizsla's on the same interface, unfortunately, so this gets complicated. Well spotted though, Sylvia. Thank you for that. So this is device ID 31. How is that not filtered out? The FTDI stuff. Pulls. You're right again. That's because it should have been device 38. There we go. We get there eventually. Okay, there's set interface. That's our get state. Data. And then it's saying, nope, not playing. Everything looks fine as far as this is concerned, except obviously it stalls. No, before I run that, break on... Let's do line 336 here. Yeah, that's the generic one. I've put Blackmagic in a bad state again. Wonderful. Actually, let's just try that. Okay, that did not work as it should have. It's not enumerating because it's running too slow. Blackmagic does this every so often where it runs the device in this kind of stop-start mode that makes it run way too slow. And then the USB controller gets really mad at me. Reasonably enough, because, well, slow. should be fine. Program counter looks fine. Let's use C instead of R. Nope. Oh, non-maskable interrupt. Ah. Okay, we're back in business. So, print USB control EP0 control. Status control L is set at 5, which is RxRDY stalled. Why are we stalled? We should not be. Neither setEnd nor dataEnd are true, and we're no longer clearing setEnd automatically. And the Rx count is also 0. Okay, that looks correct. We are using Rx ready clear. Okay, I wonder what's happening then inside of handle download here just before we return to the stack. Because we should be in a clean state ready to do this, but if we're not, that would explain things. Break, DFUs, CXX, line 82. Print EP, oh sorry, USB control EP0 control, and already we've stalled. We're in a bad state here. That's frustrating. What I'm gonna do then is I'm gonna do a debug build of DFU util so that we can step DFU util. I hate auto tools. So this wants just to be configured. And then I want to use the same invocation I had before. But I'm going to need to point it at the right path to that file, which is in dragonBoot build. Oh. I just realized I did that as a non-debug build. Because configure is pain. So SPIFlags O0OG. So, we did earlier identify the function that actually does the download side of things in DFU util, but I then closed DFU util. So, it's this file. Do download. Set up a progress bar. Where is that defined? Ah. DFU.c. Okay, so this is just emitting a control transfer, which is exactly what we're after. Because we want to breakpoint on the status return of that. 5 seconds default. Can I change the timeout? Version verbose list, detached delay, transfer size, upload size, download, reset. Wait. No, apparently I can't easily change that. What I can probably do though is if I insert the breakpoint on lines 79 there, I can then change the timeout temporarily. So, out of the way. Take care, Sylvia. Thank you for the best wishes. I hope I can figure this out too, because this is starting to really annoy me. It's simply in the fact that I've got a chip doing stuff under my nose that it's not letting me really see into, and that it's doing wrong. Which is like exactly what you don't want happening. So breakpoint wise, we've got breakpoint set, rerun this, run this, Or apparently not, because that didn't work right. Oh. I need to tell GDB that there are command line arguments it is not to interpret. That's what that was. So. USB spec for, rather not USB, lib USB spec. We are looking at the USB control transfer timeout for an unlimited timeout use value 0. There we go. It's already in a bad state by the time we get here. That's so frustrating. I'm also really intrigued as to what the datasheet for this microcontroller means by the host sends more data during an out data phase of a control transfer than was specified in the device request during the setup phase. Like, I'm pretty sure I don't really make a request myself. So I'm not sure if that means the setup packet that the host sends me or something else. It's unclear. That was my keyboard biggered up again. Nice. So to get to there, we go through this. I am inclined to set a breakpoint on this line just before I fire the actual request to the device. This is going to be coordinated debug, which is going to be hilariously fun. So I need to remove Disable will be fine. Breakpoint 1. Break on device CXX line 282, but we'll disable that for right now. Rerun the thing. Rerun this thing. Now we can do the enable 3, continue. Oops. Go. And do the same trick where we can then change the timeout. Next. USB control, EP0 control. We have a packet to be read. We have 8 bytes in the RX count. Cutiaki is cute. Why is that getting done? I meant to actually go into the routine, but that required a step, which is not what I issued. Too many things open. So 4 0, that's 1, 2, 4. The stall handshake has been transmitted. So we're stalling somewhere around there. Which is not what's supposed to happen. Disable breakpoint 3, rerun, enable breakpoint 3, next, and then step. There we go, that's got me to the right function now. So read count is 8. Transfer count is 8. They match. We're currently in the idle state, for better or for worse. Oh. Fudge. The stack is setting that data end bit early. We should be doing... This is a control transfer read. Oh, this is a bug I introduced when I merged the stack down. Okay. So if we look at past commits on Dragon USB, Couple of warnings. 80 mega stuff. 80 mega, 80 mega. So this is where we got to the current code. This is the commit. So this is where I introduced all that new logic. If endpoint else stuff. And if we look in the original logic, that's right. Where's read? It's in this commit. Okay. So the original logic if EP status transfer count or USB controller state is status RX. This is just always broken. Well, we've identified the bug. That's cool. What's not cool is how to fix it. So this read EP0 needs to not poke the data end stuff because it would be premature to. Let's see. This should be entered only when control state idle. So if transfer count or USB control state idle, or we're in the status receive state. No, status receive should probably set data end. Ah, this is where I need this data sheet again. And setting txrdy for the last data packet, unloading the last data. Oh no, that's correct, yes. Otherwise we'd set that too many times. So that will mean that we only clear that we're ready to, sorry, that we've dealt with the ready reception. So we've unloaded a packet. Otherwise, if this drops to 0 and none of these conditions match, then we set data end. Right, that should be fine. Because we changed from idle to wait here. So do the right EP thing, and that can also set data end. That logic's correct now. And because of this, data end should get set at the proper time. Well, here goes nothing. We still enumerate. I wonder if this fixed the descriptors problem. Let's find out. It should have. Uh, 1209 bad B. Hey! Would you look at that? No stall. Yeah, really? And that probably means if I now try doing a DFU run, it's not stalling out, it just times out instead. So, we did fix that bug. Ooh. I don't have to do ETM stuff. Ooh. Right, let's do some version control, and move this set of fixes back into, Dragon USB. That's a lot of stuff. Okay. And that also proves that the this was always a hack to get around us actually just doing the wrong thing. So, let us strip that out. We don't need to put it back in anywhere else. We should probably do the dealing with stalls, though. Which should be done here. That's what this code's for. Look. And there we go. This was, yeah, properly handling stall cleanup on EP0. Then this was read EP here. If we are idle, yeah. Fixed a bug in read EP. For T-ver-C, which resulted in the hardware stalling wrongly. And then in the DFU driver, that was a const zone. Const zone and const zone. Huh. Well, you're welcome that you can now use this environment that is not completely cursed to hell and use your T-ver-C launchpad at last. They're actually very handy. So let's see, another bit here is fixing check for page size overflow. added check that the download packet size does not exceed the expected exceed the max page size. And then instead of doing this, we do EP status needs arming true. And then we go and actually fix things over in USB device. So that was fix number 1. And the other bit here was... keep scroll downing when I don't want to. I want to use my scroll wheel. I am such a keyboard heavy user, it's not even funny. So there's this change here, which was done for efficiency. Because I thought it would help fix that other bug that we've just fixed. We'll come back to that. This was the zero length packet stuff. Which is needed for the fix that we're constructing. I'll come back and put those in. So we've got the zero length packet fix. We need to deal with our unhandled response here. This is write EP0. And then status phase. Yeah, we've done the status phase stuff. Cool. Actually, rather than using that console, let's actually use a proper console. This is not that optimization, that fix, not those yet, we'll come back to those. Fixed a bug in USB device which prevented data in transfers. Oh. Welcome, glass of ethanol. Thanks for the follow and welcome to the stream. Fixed a bug in USB device which prevented data in transfers, control transfers working properly. We then have added the missing status response handling code to handle control out packet, which is in USB device. Fixed some missing logic for status phase idle setup callbacks and pinged up. And then finally we get to add the optimization. Made control rights where spare double buffering space exists more efficient. So if we now try to do a git pull, we should be able to merge most of this stuff down. All this dash contains conflicts. Right. That's because line 410, the updated upstream is correct. I should have used a proper console. Visual Studio Code binds Control K, so does Nano, which is unfortunate. So if we do a git diff, we should see one fix to the descriptor header, one fix to DFU types related things. Well, fix in quotes. It's actually a thing I did earlier to bodge the IDE not recognizing stuff. And then we need to grab those changes to device. So let's do that. Grabbing the stuff for the device. That looks good. Let us build that. And add all of this stuff, which is mostly to do with tightening up checks around like request handling, so we don't end up in the wrong chunk of code. Tightened up our validation in USB device, request handlers to help steer execution more correctly. Cool. So, with that done, let us run the analyzer again. I'll do it the dumb way. Put the firmware back on the device, and then... Gosh, I've done so much on this console. DFU util list, and attempt to do a download, which will time out. What are we seeing through Vizsla? We're not really. That's interesting. We should have seen stuff happening with OpenVisla there. Not good. Just gonna restart my OpenVisla. And actually, I'm gonna switch to using Wireshark again real quick, even though it's very annoying to read the output of Wireshark. I'm just going to reboot the device. And if we try that. Control transfer in. What's the control in? Is that get state? That might be get state. Yeah, that's get state, and we're not actually answering it, interestingly. Okay, let's try USB, because this is too difficult to read the output from. Now that we've fixed the stalling, USB might actually work. And indeed, there's our data going out to the device. Which is not what it thinks it is. And then we've got our dataless ACK, our zero length packet, and then it gets lost when it tries to do a get status. libusb error timeout. So we can use a debugger. And we are looking in here. Let's see. So get state sorry, get status should always work as long as the direction's correct, which it is. So the only way it can not work is if the stack is in a bad state. Which I wouldn't put it past the stack. I mean, I did write it after all. In here, we are going status transmit, which when it completes, we should fire this. Firing this code that puts us back into an idle state. So in theory, at that point, we should see download step done fire. Which is that breakpoint. And then once we've seen that fire, we should then see get status. And we want to do that for where config.state is DFU state t download sync. That's because that's USB DFU types. You have to be fully qualified. Run. Oh wonderful. Got back into a bad state again. That's broken. I'm gonna have to reboot Blackmagic Probe again. USB was having a moment. So let's put the breakpoints back in. Okay, it enumerated. That's good. Okay, so we are getting hit with download step done. This is indeed from handle control out packet. and that second breakpoint never fires. I am of the mind then to try and get some breakpoints in, shit, it got closed again. DFU load, download, DFU get status here. Because this should, in theory, be something we can control entering the breakpoint for. If we break DFU load C line 133. Yeah. Yes, Aki. It's going. I fixed the big bug. The one that had me holding my head in my hands. You'll laugh at it though. I'll explain it off stream. It's a doozy. Aww, I'm sorry to hear that you're in pain. Okay, that's... That's why the stack's locking up. Okay. Yeah, that's my fault. I am a bad wife. That's what that surmises as. All good. I am having breakpoint hilarity, as you can see. I'm having to break and debug in both DFU util and my own code at the same time. Synchronize breakpoints, which, yeah, oof indeed. Yeah, I indeed rest in pieces. Rip in pieces. So I'm thinking, download step done. When that fires in here, we go into idle. Actually, that's happening in controller out packet. Yes, yes, indeed. I think this actually needs to go to idle. That goes to idle. And then we do... And... the state is idle to enter into that code. That should make the phase change happen one step sooner, and that should stop us accidentally coming back into this rather than into handle controller setup packet. Sorry, handle setup packet, which is where we should be going, because this is all driven by the USB control state thing, which is dumb, but so this is break in DFU CXX line 66. We'll also want the breakpoint again on 109. We'll disable that for a moment. I just noticed that that actually went and put the breakpoint in the wrong spot. Why do you keep making that line 13? Anyway. We enumerate. So this is USB control EP0 control. Okay, I think what I'm gonna do to fix this is, because that didn't work, clearly. Although, did I actually build? That's a good question. No, I did build. So as that did not work, let's undo that change. And here, if we've gone idle, do that if because we've not yet done a read. If we're in the status phase and we've done go to idle, handle setup packet, I think it just can be a given that because we're here, because of the architecture of this chip, we need to call handle setup packet. Yes, that should definitely work. Before I do that, info break. Right. So we've re-enumerated. And if we rerun this, So we do download sync, step, six's result. Hey, that looks like that worked. What do you know? We didn't handle breakpoint that we were supposed to handle, but okay. So if we continue on both sides, and if I disable breakpoint, oh, this gets stuck then in what mode is that in? We need to go to download idle. We get stuck in download sync. So it's almost like tick is not running. So let us then we do break dot info break to be get rid of that breakpoint. Break on DFU CXX line 137 and also in right, that's in the bootloader main. Or no, sorry, platform. So we can break on line 91 here. So enumerated. And then we want to enable one, rerun, change the timeout to 0, disable one, and continue. And none of those breakpoints are firing, meaning that the start of frame stuff's not firing. That's why this is broken. Cool. So why is the start of frame stuff broken? So, info break, delete 5 and 6, break in 4CXX line 473. And if we rerun, well, before I rerun, if I restart Vizsla, okay, that's interesting. Print USB control int status versus enable. Starter frame is 8. So the starter frame bit is set, but we never end up here. And enable is set up in such a way as this is 08 really, so this is 2C and 08, which comes out to a value of 08. Oh, balls. I know why. That's why. We had an early exit in there. This is 472. Oops. Nope. And if we rerun that, there we go. And if I now break on that and break on that, we rerun, we re-enumerate, and I see. Interesting that didn't break point properly. Oh well. Anyway, so if I get rid of that for a moment, flash busy, print flash control. I want to delete breakpoint 10, I think that was. Yeah, 10. If I actually exit out properly. And if we do a full cycle. Okay, we've been re-enumerated. And now... Hey! That was good. Status 14. Why is it going to 14? Status and transfer. That is... That's the last download request. Which... We answer... this incorrectly. Interesting. Huh. I'm having that moment of, wait, we got almost there. We got to the end of the download, and then it just went wrong. But if I reboot the device... like that. Interestingly... Oh, interesting. It did not actually boot the firmware I've just flashed. It did go back into bootloader mode, which is a bit weird, because it shouldn't have. Because there's valid firmware on there now, if everything's worked right. Let's actually find out. tar x dev gdb tty bmp gdb. It got everything to the... It got all the way to the last little bit. So it's got valid firmware on there now, in theory, but that's just what we're going to check. If we read... examine the first 64 words in hexadecimal, at 4000. Well, that's actually empty flash right now. Interesting. So that would be why it didn't boot. Wrong console. Error, too many consoles. So we go through, that's download sync, 3. Yep, and then idle is 5. Also, more importantly, Obliterous, actually, it didn't write any of the data to the Flash pages required. They're all blank right now. So something's probably wrong with the way I'm doing the Flash writes. What is that request? That is download. Value is set to 11. Apparently I don't have the header for that open right now, that's annoying. Am I actually even checking value? I probably should be. Yeah, that's not currently doing anything with value. Why? Why is it not, more importantly? Oh, because it's the block number. Okay, I don't care about that. This is the special zero-length download packet. That's right. We're not handling that properly. Okay. If packet length, then we do one thing. Otherwise, we do a different thing. Because I think what might be happening is we might be hitting stall. We then have handle set interface. That all works as we wanted it to. I need to debug why write isn't working. That's gonna be fun. Flash busy. We'll go to download idle. No, protocol's live. You can't do this faked. What I'm looking for, let me see if I can get this to do it again. If I break in... here. Oh, it helps if I run the code, but before I do, I need to figure out what breakpoint I actually want to set. I should do the breakpoint in right, which is in here. 103. This is where I want to do... Where's it gone? The thing I was doing where I can turn off the timeout. Because I really don't want the timeout here. Step. There, that's what I'm after. Oops. Huh. Apparently it just works, except write is never called. So state goes to idle, no error conditions present. So we fixed that bug, but this never called write at any point. I wonder what this is doing on line 147. Not that one. I will want to restart that though. That one. Make sure I've not got too many breakpoints. Nope, okay, not. Restart it. Which has renumerated it. Bollocks. I did not want it to go through to timeout, but oh well. It doesn't matter too much. List. Info flash state. Not info. Print flash state. So, byte count is for some reason 0. Okay. Ah, because I never finished that particular bit of code. Haha. That would do it. So here, flash state, byte count should be set to packet length. So we set up the erase operation, but we didn't set that up, which is the mistake. We should also make sure offset is 0, just for sanity. So it really always should be. And it does not hurt to add that. And then platform, we just never landed in there because it was never able to before. So if we run that, which is re-enumerated, oh, I never reset the breakpoint up. That's why that misbehaved that time. Oh. Really? Anyway. Okay. Flash buffer size is not correct there. Ah, right. Ah. This was that whole... There are two different buffer sizes I need to work with here. There's the flash buffer size, and then there's the... flash page size. Oh no, the buffer size is right. Why is that? DFU flash buffer size. Okay, that might now actually do the right thing. Yeah. Okay. We now do, no, continue. Print, flash buffer size, print amount. Okay, that took a bit more time. And if we now do an examination of the first bytes... Yes! It DFU programmed! Oh, that's glorious. So detaching from the target, if I reboot the target, it's still coming up in the bootloader, but at least it DFU programmed. And after I've restarted... Okay, that's all still there. That's good. I'm not sure why it's not coming up in that mode, but that's good. Just restarting Blackmagic Probe real quick. Aww. Thanks, Aki. So we should do some version control real quick. If we do git diff, we can see we've changed quite a few things here. And we also need to consider the changes I've had to make to Dragon USB as well to be able to fix things. Like, a lot of stuff has changed. I'm just gonna... Oh gosh, that's the name of the USB driver for USB, right? Gosh. So descriptors, let's start here by breaking stuff to fix stuff. The best kind of breaking things to fixing things, right? It's just what you do. There's one break, and then DFU 2. Broke the protocols, the descriptor protocols to fix them, and added the DFU mode protocol. The next thing I did that we need to patch in is fixing this. Which is drivers DFU. fixed typo in the USB DFU flash buffer size definition. I don't actually want to change those types, so that can stay exactly as is. Device needs to have the patch here for handle setup packet. Fixed a bug that meant the USB stack could mishandle setup packet. And then we've got lots of DFU driver stuff. So first thing to do in the DFU driver then is indent if packet length else state, no, config state is DFU state, DFU idle. Fixed the lack of handling of the final 0 length download packet. That's DFU. We then have the flash state debacle. Actually, that's packet length. Is there anything else I've done there? So we've got, that's just indentation change. Erase, Status member for transfer count needs arming. Step done. Yeah, okay. Added setup for the flash state variables that control the write process. Let's see. That set of changes can get ignored. There's then this fixed to core. Which was this core. Fixed the ability to enter the soft handling when there are no endpoint requests to handle. And if I now do a git restore, I think it is, yeah, of include USB drivers, DFU types, and sources, drivers, DFUC, XX, we're clean. Gosh, there actually hasn't been very much code added today, but it's been a lot of bug fixes. Let us do git diff here. So we've got the firmware zone. We don't want to add that yet. We do want to do that. Find the firmware zone for the DFU driver. There's script or fixes due to misunderstandings and spec mistakes made. So in the descriptor side of things, I'm copy the deleted line, paste it back in. I do at some point want to, I think, try and get the ST style descriptors working, although it's not really required. So, I've got. I don't need that debug session anymore. We don't need that anymore. Excellent. What else that needs to happen here? I need to debug why write isn't, well no, not why write isn't working, why the must enter bootloader is always triggering when it shouldn't be. So if we do target extended remote dev tty bmp gdb monitor s, which is the swd scan attached to the first one, load. Also, we can now ninja size. We can reduce the bootloader reservation from 16K down to 8K, because we've done the bootloader in 8K. Yes. Hell yeah. And hand back 8K back to the firmware. Let's see. Reboot to firmware. I want to put a breakpoint on line 68. Thank you. The really funny part is I've not actually tried to keep the firmware small. C++ is just so good at giving me optimization opportunities. I get it for free. I haven't yet turned optimizations on. I'm on OG. That leaves me 3 levels of optimization above that, 01, 2, and 3, and LTO, to make it smaller. Yeah. I've had that happen before, but not with this firmware. I was doing some very, very naughty things that were all undefined behavior. I probably can't get it down to 4K, but certainly 6K target is possible. So, must enter bootloader. I need to try and figure out why this is angry. So if we do a inspection, the firmware is still there because we've not reloaded over the top of it. So the firmware that I put on the device using the bootloader to do so is still all there. Let's see what happens when I run. There we go. So for some reason we end up in the return true path. That's annoying. Reset causes. What are the numbers for those again? So I can get rid of USB now. Because we've done that bit. It works. So in the peripherals here, we've got the system control block. Sorry, not peripherals. In the system control block is reset causes, which, let's see. That was software. Software is the cause of the reset. Yeah, that's true because I used the debugger to reboot. I'm gonna restart again, but this time I'm going to set the reset cause to power on reset. And it still goes to the return true branch. Because I messed up the Logic. Wonderful. Take care, Blit. Have a good dinner. So, if it now goes through step, step, I just managed to get that logic completely wrong. Yeah. Yeah. Yeah, you should go sort dinner, dear. Be a good girl. I know you can be. Okay. Hey, I get it, dear. I get it. Stack pointer is not all Fs. Reboot to firmware. Oh. And the firmware boots. I see a green light. And we did. For a moment, we actually enumerated as a SPIFlashProgrammer. So if I now do a proper power on reset, firmware boots. Ew. 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 Bootloader works. With that, I've been streaming nearly 5 hours, and we got it working. I am pleased to say. We'll quickly do a little bit of version control because I did just make some changes to the bootloader. So we'll do git commit, fixed some broken logic in must enter bootloader. Yeah. And there we go. With that, thank you all very much for watching, and I hope you maybe learned something, found this mildly entertaining. And next stream, I will be working on the version of this for the keyboard, so we can finally get back to MX keyboard. With that, bye for now.